Hi, everyone. Let's now use a two-way frequency table to compute conditional probabilities. We've seen this table before. So remember, there's a class of 26 students, all of them passing, all of them sophomores, juniors, or seniors. And we had this data on the 26 students in the class. And all 26 students are accounted for in this table. So the grand total is 26. You can check that. Everyone's passing, and there are no freshmen. Now, first off, let's ask, what is the probability that a random student in the class is getting an A? That is, what is the prior probability of a student getting an A before the student says anything to the tutor? Later on, one of the students will call the tutor and honestly tells the tutor, I'm a junior in the class. But before the student says anything to the tutor, what's the probability that a random student has an A in the class? Then, after the student informs the tutor that they're a junior, what is the conditional probability of the student getting an A, given that the student is a junior? What's the updated probability? Because the fact that the student is a junior is information, and we can update the probability that the student on the phone call is getting an A. C, let's say that instead the student honestly tells the tutor, I'm getting an A in the class. What then is the conditional probability that the student is a junior, given that the student is getting an A? What's the probability that the student is a junior, given that the student is getting an A? Are these going to be the same? We'll see. So take a look at this table, do whatever computations you need to make, try to answer these three questions. I'll give you 1 minute. Okay, before the student says anything to the tutor, what's the prior probability that the student is getting an A? Well, it would help to know the total number of students who are getting A's. So this marginal total would help. 1 plus 5 plus 2 is 8. 8 students are getting A's. Of the 8 students, right? Well, one's a sophomore, 5 are juniors, 2 are seniors. Now, since there are 8 students getting A's, 26 students total in the class, that means that the probability that a randomly selected student in the class is getting an A is 8 over the grand total of 26. So 8 over 26. The number of trials for which the student's getting an A over the total number of trials, the total number of students. 8 over 26, by the way, is about 0.308. That's the prior probability of a random student getting an A. If you want to think in terms of a Venn diagram, so here's our sample space, okay, consisting of 26 students. We can say that the size of the sample space is 26 students. Right? 8 of them are getting A's. Eight of them are getting A's. So the probability that a randomly selected student is getting an A is 8 over 26. Imagine that this is 8/26 of the total area inside the red box. It's like throwing darts. What's the probability that a random dart thrown at the red box will hit the area inside the purple disk? 8 over 26.